What about for novel applications for identification of novel targets? There's an example of that here with a ketogenic diet that is used to be an effective treatment for refractory epilepsy. So we're kind of covering the spectrum of all diseases from cardiovascular disease and multimorbidities, liver disease, and now we're talking about more neurological disorders. You can see, again, metabolics and metabolism is relevant across all disease states because every disease requires changes in biochemical steps. So it's known, this is work done by Elaine Tsao at UCLA, and it was known that the ketogenic diet is useful or beneficial or effective treatment for refractory epilepsy, but the mechanism wasn't known, and they wanted more to develop more targeted, more effective therapies, more consistent therapies around this, and understand the mechanism of the ketogenic diet. And the investigators thought that there was a microbiome component in all this. So they worked with us on a discovery approach to characterize or profile stool samples and circulating plasma samples from preclinical model of refractory epilepsy. And they found, of course, that the ketogenic diet was beneficial in this model. And through the profiling of the gut and circulating metabolites, they found that there was a decrease in the responsive group, the group that responded to therapy with a ketogenic diet, in a specific set of metabolites called gamma-glutamyl amino acids that derive from a specific enzyme that drives the class of these molecules, that it decreases in the response group. And they knew there was a microbiome component, so they did antibiotic treatment to see if to test the power of that association. So they treated these animals with antibiotic to knock out the microbiome, and they lost their effect. And then they reintroduced a specific strain that was able to recapitulate the ketogenic diet effect. And all these correlate with decreased levels of stool and circulating metabolites of this class of molecules, gamma-glutamyl amino acids. And this ultimately results into a change in the brain, hippocampal slices, again, profiling these where the changes that are occurring in the gut and the circulation result in changes in the GABA-glutamyl glutamate ratio in the brain that associate with better outcomes in the ketogenic diet. So what this really suggests is that targeting the nodal regulator of the enzyme that makes this could be a good target. They've developed an inhibitor specifically to gamma-glutamyl amino acids, the enzyme that makes all these this class of metabolites, and they saw a significant increase in the effect of their phenotype in the absence of any ketogenic diet. So they saw a direct inhibition from oral administration into animals of an inhibitor for gamma-glutamyl amino acids. And of course, they worked out the mechanism behind that. And so they identified a novel target, showed efficacy of inhibition in this model, and this formed the basis of a new biotherapeutic company that has continued to develop that specific inhibitor, as well as inhibitors using metabolic profiling across all different neurological disorders.